we'll probably get started in a minute or so. So thank you again as you are coming in. Appreciate you joining us today for our Student Voices webinar. All right. Welcome, everybody. Since we have a pretty busy day today, we're going to go ahead and get started. Just as you're coming in, please feel free to introduce yourself in our chat. And we just ask that you would mute your microphone and disable your camera unless you're actively using them. But again, my name is Ella Spiegler, and I get to serve as your student moderator today. Thank you so much for joining the Ohio River Basin Alliance discussion series. ORBA is a collaboration of stakeholders with a unified voice for the Ohio River Basin, which consists of 14 states with over 500 members working to sustain healthy ecosystems and vibrant communities within the basin. And I'd like to thank the chair of ORBA, Chris Lorenz, with Thomas More University, and past chair Craig Butler with Muskingum Watershed Conservancy District. So much for this opportunity to be able to speak. Um, thank you for the opportunity, or thank you to the sponsors of this webinar, ORSENCO, the Foundation of the Ohio River Education, Ohio University's Williams School of Leadership and Public Service, and the Kentucky Association of Environmental Education. We are so grateful for all that you do, and we appreciate this time together. A little bit about myself. I'm Ella Swigler. I serve as an AmeriCorps volunteer at Jefferson Memorial Forest, and I am in the Environmental Education Leadership Corps. So, and I am a graduate from U of L in Sustainability and Environmental Science. Just to cover a few quick announcements before we get to hear our speakers. We have one this time, and it will be that ORBA will be holding an additional Ohio River Basin Discussion Series webinar this year in mid-April at noon, where members of ORBA will present the Ohio River Basin Restoration Initiative plan to the public. Please register for this event on the ORBA webpage on ORSENCO's website, and the date will be released soon, especially as you register. So with that said, I am excited to announce our speakers for this webinar. We have Eli Hall, Sarah Nelson, Sujan Tielmiashina, and Lillian Kajek. So thank you so much to our amazing presenters. And with that, I'm going to let Eli get his slides set up, and I'll give a few more details as Eli gets ready. Cool. So Eli is going to get to tell us about the long-term trends in algae bloom extent and the severity in the reservoir. And he's a PhD candidate in the Geology and Environmental Science Department at the University of Pittsburgh. So I'll let you go ahead and take it away. Thank you, Eli.
Hey, thank you, Ella. Yeah, hi everybody. I'm excited to talk about the research that I've been doing for the past couple of years. This is just one chapter in my dissertation, but um, yeah, we're exploring the history of the Allegheny Reservoir by reconstructing chlorophyll A dynamics using Landsat. And the reason we're doing chlorophyll A is we can use it as a proxy for algae bloom occurrence. Um, okay, so sorry. Okay. So algae blooms are becoming more frequent in freshwater systems, specifically closer to us. In 2015, the Ohio River had a 650-mile long continuous algae bloom that extended from the Pennsylvania, West Virginia border of the Ohio River all the way down to Tell City, Indiana. Now, this occurred again in 2019, not as long, but this is hitting closer to home now. And nationally, we're seeing that the annual number of news reports for algae blooms are on the rise. Here on the right, we see from 2010 to 2019 a dramatic increase in the amount of algae bloom reports in national news. Okay, so jumping right into it. What is wrong with the Allegheny Reservoir? Well, since its creation in 1965, they've seen algae blooms as far back as 1972. Now, these were intermittent, did not occur annually up until 2012. Now, compared to other reservoir systems, there's no obvious nutrient pollution source coming into the reservoir as it's a mostly forested land use cover for the watershed, very little agriculture, and even less so in developed areas. So your common pollution sources that are fertilizers and wastewater aren't typically seen in this area. And this is really problematic for the Seneca Nation, and you can see their Allegheny Reservation in this yellow boundary here, and it really just exacerbates more problems that they have had since the reservoir's inception. And so I've been collaborating with the Seneca Nation of Indians as well as the Army Corps of Engineers Pittsburgh District to really determine what is going on in this reservoir, as there's no, as far as I know, there have been no published studies within this watershed. And so the two questions that we came up with are, is there a distinct difference pre and post 2012? That is, what is making this annual bloom occurrence in 2012 happen? Or is it just we started noticing it in 2012, but they've been annual before? And the second, is there an increase in chlorophyll A concentrations and algae bloom size from 1984 to 2023? From these two questions, we formed a hypothesis, which is there's an observable increasing trend in chlorophyll A concentrations and bloom size from 1984 to 2023. And to try to tackle this hypothesis, we developed four objective questions. The first being, are there areas that are routinely in bloom-like conditions? Is there a trend in chlorophyll A concentrations through time? How are chlorophyll A concentrations and bloom size varying over time? And lastly, how does bloom coverage differ between the entire reservoir and only looking at the Seneca Nation portion? So the Ohio River region has a very sparse amount of chlorophyll A observations when compared to neighboring regions. From this map, you can see that there's just a little over 6,500 chlorophyll A samples within the Ohio region. So you're not able to really understand what is going on in the Allegheny Reservoir and the Ohio River region just by this amount of samples. So we turn to remote sensing and machine learning as an alternative to the lack of in situ samples. Um, and the reason for that is we can look at the spectral wavelengths or the spectral curve of chlorophyll A and its spectral response. Specifically, when you look at this bottom graph here, you see chlorophyll A in this blue line, and you can really see a peak between 400 and 450 nanometers. So we can really start estimating chlorophyll A using this. And so we use Landsat, the Landsat satellite series, Landsat 5, 7, 8, and 9, as well as a matchup data set named Aquasat to train our model. So all Landsat data was collected using Google Earth Engine. We've applied various filters on our data before we ran our analyses. And I just put three here. The first being we ran a 40% cloud cover limit. So any image that had more than 40% cloud cover, it didn't matter where the clouds were, we immediately got rid of it. Additionally, we only looked at images from May to November as talking with collaborators as well as looking at past studies. Peak bloom season is really May to November, so we didn't want to get anything that wasn't peak bloom season. And lastly, we wanted to make sure that we only retrieved water pixels. We did not want to have terrestrial pixels influencing any of our results. So to do this, we applied a dynamic surface water extent masking algorithm. And essentially all that does is at the individual image level, it will make sure that all terrestrial pixels are masked out and we only get water for that individual image. And like I said, we used a matchup data set named Aquasat. And as we saw in the previous slide, the Ohio River region does not have a whole lot of data, so we expanded our data set to include the Great Lakes region, the Upper Mississippi, and the Tennessee region. In total, that was about 25,500 matchups used for training and validation at an 80% training to 20% validation split. So to tackle our first question, are there areas that are routinely in bloom-like conditions? We created what we call an exceedance threshold map, which you can see on the right here. And all this is showing is at the individual pixel level, how many times or what is the percentage throughout the entire time frame that an area goes above our bloom threshold of 10 micrograms per liter. And so you can see in the northern portion of the reservoir, it's extremely high. It's exceeding at least 60% of the time from 1984 to 2023. And that's alarming as one, we knew that this area was where bloom formation occurred. However, we weren't expecting that this area would be exceeding bloom-like conditions at least 60% of the time. For a second question, is there a trend in chlorophyll A concentrations through time? We applied a Mann-Kendall test into our data, and all this details is that if as long as your data is in chronological order, it will determine if there is a statistically significant trend. And so here in the left portion of this figure, pixels or areas that do indicate a trend are in green, while no trend is in black. And so you can see that over 95% of the reservoir actually has no trend. But when you look at specific areas, like the northern portion, you're starting to see that there's areas that do indicate a trend. Now, to determine if it's an increasing or decreasing trend, we can use the send slope product of the Mann-Kendall package that we used in R. And this details if it is increasing or decreasing. So you can see in that northern portion, one, we know it's a trend and it's increasing by 0.04 micrograms per liter of chlorophyll A per unit of time. And that may not sound like much, but over a nearly 40-year time scale, that does add up pretty quickly. And for our third question, how are chlorophyll A concentrations and bloom size varying over time? In the top graph here, details the bloom concentration, which is on the y-axis, and the time over the x-axis. And what we can really see is there's not a whole lot of variation that occurs. When you look at whole reservoir averages, it's mainly situated around 25 micrograms per liter, and most are high concentrations and slight variations occur mostly in our earlier years. But that's different when you look at bloom area, which is in our bottom graph here, where it still varies. It doesn't vary a whole lot up until about 2010, where it starts to vary quite significantly, which may have spurred this whole discussion of annual blooms occurring in 2012 onwards. And lastly, how does bloom coverage differ between the entire reservoir and the Seneca Nation portion? Well, to no one's surprise, the Seneca Nation portion does have a higher percentage of bloom coverage at about 53%, and the total reservoir has an average bloom coverage of 33%. Now, I think that's alarming that at any given point between May to November of 1985 to 2023, a third of the reservoir is under bloom-like conditions, and I think that's quite alarming. And when you look at the Seneca Nation portion, over half of their territory is under bloom-like conditions, really exacerbating the environmental justice issues that they have been facing since the reservoir's inception. So I just want to leave with three takeaways. First, the northern portion of the Allegheny Reservoir exhibits algae bloom conditions 60 to 100% from our time range of May to November 1984 to 2023. Second, while there is no statistically significant evidence to indicate bloom trends throughout the entire reservoir, when you look at specific areas, i.e. the northern portion, you can start seeing that there are statistically significant trends in increasing bloom concentrations. And lastly, algae bloom percentages are disproportionate when comparing to the total reservoir to the Seneca Nation portion. With that, I thank you, and if I have time for some questions, I'd gladly take some.
Absolutely. Thank you so much, Eli.
Mhm.
I'll open the floor for any questions you have about a minute and a half.
Thanks, Eli. Quick question.
Mhm.
So you said the land use was nearly forested, very little agriculture, maybe 9%, I think, low development. So what do you think is attributing these algal blooms to? And did you look at any phosphorus concentrations over that same time period, or the septage or sewer outfalls, things like that?
Yeah, so that's actually my third chapter of my dissertation is we're looking at stable isotope biogeochemistry of specifically nitrate stable isotopes to try to figure out where these or what these pollution sources are. And so upstream, a city named Olean does have a pretty frequent amount of wastewater dumps. I think over 45 of them in the past 20 years. And so we really thought that would be our, the smoking gun, as it were. But it's really not looking like it. Preliminary samples indicate that it looks to be soil derived, soil nitrogen derived. And so I would love to look at phosphorus concentrations, but there's just very limited data for really phosphorus or nitrogen. So we're doing the best we can with with what we have.
Thank you.
Mhm.
Great. Thank you again, Eli. I'll go ahead and introduce our next speaker. We get to hear from Sarah Nelson, who will share more about long-term water quality trends. Sarah is pursuing her degree in civil engineering from West Virginia University, and she will complete her degree in the winter of 2025. Thank you so much, Sarah.
Thank you, Ella. I'm going to go ahead and share my screen. All right. How does that look? Can you guys see it? Perfect.
Perfect.
All right. So, like Ella said, I'm going to be talking about the long-term water quality trends in the Monongahela River Basin. Starting off with a little bit of background, the West Virginia Water Research Institute founded Three Rivers Quest, or you might hear me call it 3RQ, in 2009 to monitor the water quality of the Monongahela River and its major tributaries. 3RQ's creation was, in fact, the direct response following the Dunkard Creek fish kill in 2008. It's a major tributary of the Mon River, and it nearly wiped out all of the aquatic life. It's very devastating. WRI uses this data to evaluate the impact of coal and oil and natural gas industries. Acid mine drainage treatment systems were also installed within the tributaries, a few of the tributaries that we identified as an issue, and a voluntary discharge management plan was implemented by local mine operators. We developed this for them, and it kind of just tells them when is the best time to discharge their waste as to not really impact the tribs, which will then really impact the Mon. This was all part of the 3RQ program. 18 sites total are monitored monthly, where several water quality parameters are quantified. We have 6 main stem sites at different miles of the Mon River, and the rest are tributaries. A couple of these I will point out, White Day Creek and Robinson Run, were not included in this portion of the study, just because they had incomplete data sets. There were periods of time where, due to funding, I believe we did not sample those sites. All right, moving on to my objective for this study. Really what I wanted to do was examine data sets obtained from 3RQ for trends in the water quality of the Mon River Basin. Specifically, I was really interested in acid mine drainage signal parameters. So these are things like pH, electrical conductivity, sulfate, and dissolved metals. For my methods, first, we started out with data collection, of course. So there's me sampling at Robinson Run. It is the stream that is most impacted by acid mine drainage. And consequently, this was not included in this portion of the study. So the statistical tests that I'm going to talk about here were not performed on this stream. But I used data from monthly sampling trips between 2009 and 2023 and compiled and sorted them using Excel. Then I ran statistical tests. So these were 4 non-parametric statistical tests. I used the Mann-Kendall trend test, the seasonal Kendall trend test, and then both of those adjusted for discharge. In R, I used the RKT and Lubridate packages to determine these. Finally, for my significance, I used slopes of significant relationships with an alpha value of 0.1 and estimated these using the Thielsen estimator. All right, now I know these results look a little bit crazy and overwhelming, so I'm going to break it down for you. Each of these 4 boxes, if you can see my mouse, represents the 4 non-parametric statistical tests ran. If 3 or more of these boxes have the same symbol, then we're going to call that a significant trend. So for example, electrical conductivity at M11, we're going to call that an increasing trend that's significant. To summarize that for you, for our main stem, we have decreasing trends overall for chloride and sodium. Then for a lot of our sites, we had decreasing trends in total dissolved solids, magnesium, sulfate, and electrical conductivity. And M89, so Mon-Mile 89, had a decrease in manganese. Increasing trends, we saw a lot of increasing trends in pH, alkalinity. These are both really good things. I'll point out decreasing trends, that's what we wanted to see. Acid mine drainage is, of course, very high in metals, so it's really good that we're seeing a decrease there. As for the increases, it's great that we're seeing increasing trends because acid mine drainage, of course, is acidic and has a lower pH and is not alkaline. Moving on to these last 3 points I have here. So we have acidity and iron increasing at Mon-Mile 61. It's very interesting that this is only increasing at 1 site. I would really love to do a further study as to why maybe that is occurring. And also aluminum was increasing at Mon-Mile 82. Of course, that's also very interesting, and I would love to see as to why that is happening. Moving on to our tribs. So we had decreasing trends for several locations in sulfate, magnesium, chloride, sodium, and total dissolved solids. Again, this is great and exactly what we wanted to see. Increasing trends for our tribs. Overall, we had an increase in pH and alkalinity, which is great. But then here's the aluminum again, an increase in Dunkard, Cheat, and Decker's Creek. So again, really interesting that these dissolved metals such as aluminum and iron are increasing only at some sites. I will say acid mine drainage, when we look at that, some of its highest metal content is going to be aluminum or iron. So it's very characteristic of acid mine drainage. But yeah, it's just peculiar that it's at a few of those sites. And just as a general thing, Taggart Valley and 10 Mile Creek had the fewest significant trends out of all of the sites we analyzed. Concluding here, overall trends in the AMD signal parameters in the main stem were generally improving or showed no trend. Over 12,000 stream miles are impacted by acid mine drainage in the US, with a large concentration of impact in Appalachia. Specifically, West Virginia has 2,500 stream miles impacted by acid mine drainage. The Mon River provides drinking water for more than 1 million people, and it's the source water for more than 15 drinking water plants. That's why we really want to improve the water, of course, if not for any other reason. 3RQ provides baseline data to determine and quantify the impact of industry on water quality in the Three Rivers and helps researchers and industry professionals develop plans to improve it. Lastly, evidence presented in this study supports the continuation of long-term water quality monitoring programs like 3RQ. And here are my acknowledgements. Thanks so much to West Virginia University, Three Rivers Quest, the Colcom Foundation, and USGS. And I will take any questions.
Thank you so much, Sarah. That was awesome. Yes. I'm looking in the chat for any questions, and feel free. We have a couple of minutes if anyone wants to ask any questions to Sarah now.
Hey, Sarah, quick question. So you attribute the improvement that you saw to basically a management of the releases, right, rather than any kind of stopping of the releases.
Yes. So 3RQ, the monitoring program that we studied, as part of their program, there is, of course, the long-term water quality monitoring, but we also, so we did work with the mine operator specifically to develop these voluntary discharge management plans, kind of to tell them when to discharge. Like, for example, this is common sense to us, but don't discharge your mine waste when there are super low flows because it's just going to there's going to be a concentration of that yucky stuff. But also, we installed several acid mine drainage treatment systems along some of the tribs, which also greatly improve the water quality, as you can imagine.
Thanks.
Yep.
Great. We also have a question in the chat. It says, has coal production changed during your study period?
That I don't exactly know the answer to. I would be happy to get back to you on that. One thing I will say is Robinson Run. So that if we go back to my method slide, this is Robinson Run. It is heavily impacted by acid mine drainage, and there is an active mine that is discharging into it. I would say if I had to guess, there has not been a change. This mine has been active for years. Along the other tribs, if there has been an increase or decrease in mining, there hasn't been that much of like we haven't looked at the data and been like, whoa, like this is crazy. So generally, I would say that there hasn't been a huge increase or decreasing in mining activity.
Those active mines that are discharging to the creek, they're permitted, right? So they're part of the MPDS system. Do you see that the discharges are in compliance, or how often are they, exceeding their permitted levels?
That's data I do not have a hold of. I would be happy to get back to you with any of that data, but generally we find that they follow the management.
Thank you so much. If we don't have any other questions, we can go ahead and move on to our next presenter. Thank you again, Sarah.
Thank you.
We're going to get to hear from Sujan Timilshina, and we are so thankful to hear about his research on comprehensive water quality assessments and his work developing models for algae bloom reduction. Sujan is pursuing his graduate degree from Youngstown State University in the Department of Civil and Environmental Engineering, and he plans to complete his master's degree by December 2025. Congrats. So go ahead and take it away. Thank you.
Am I audible right now?
Yeah.
Yeah.
You sound good.
Okay. Good afternoon, everyone. Before I dive into my research, let's just start with a fun fact. Did you know that the lakes, just like humans, can have a bad day? Sometimes they get moody, sometimes they get cloudy, and sometimes they just decide to throw an algal bloom party. That's what my research is all about. Monitoring of Top Pond Lake for comprehensive water quality assessment and developing models for algal bloom reductions. Let's get ahead. Firstly, introducing my study area. This is Top Pond Lake, which is located at Harrison County, with a surface area of 9.5 kilometers square and shoreline length of 47 miles. And it's a shallow lake with depth of just 10.4 meters. And is managed by MWCD, Muskingum Watershed District County. And while talking about the motivations of this research, it's definitely algal bloom. Top Pond Lake has been seeing algal bloom from past recent years. And we know that algae releases neurotoxins, which is bad for human health. And the major concern is that this lake is the water supply source for Cadiz village. And other thing is that 85% of the watershed is forested, and just 15% of the land contributes for agriculture and other runoff. But then too, the lake is seeing some algal bloom. And the question is why? Is this because of internal loading? That is our research for. And the basic questions that I have for this research are: what are the key factors that driving water quality changes in Top Pond Lake? And how does algal bloom formation correlate with environmental and hydrological factors? as well as we are measuring the water quality index for the Toppan Lake water quality health, and how can hydrodynamic and water quality models improve the lake management strategies that we are studying for. Okay, the objectives of the research is that monitoring the environmental factors that influence the algal growth using YSI exosomes. We are using 7 different sensors with YSI exosomes to measure the physiochemical parameters. And we are using 1D water quality modeling like Minley, Q8, QSWAT for algal bloom reductions. And we are comparing those 1D models with 3D models like EFTC to see the algal bloom and its reduction remedies. Apart from that, we are doing water quality index calculations to measure the lake water health or to monitor it. And now here you can see that this is the data collections and data collections method. Firstly, you can see here there is a image of an instrument which is called as YSI exosonde. It is equipped with 7 different sensors. I will explain it later for you. And below you can see me measuring those data. During the summer seasons, I bi-weekly measure those data proportionally in that lake. And during winter, it is almost impossible to measure those data physically. So we have deployed a buoy on that lake, and it is constantly measuring those data for us. On the next slide, you can see that here is the data collections protocol. We are collecting those data bi-weekly there and on different 11 locations. You can see it on the map of lake. There are different 11 locations where we are measuring those data at every 1 meter depth on every location. And instrumentations and winter monitoring, for that we are using YSI exosomes as I explained earlier, and we are measuring city depth data also for seeing the turbidity of those lake. And for winter we have deployed a buoy. And data types, we have measure physiochemical parameters like temperature, pH, specific conductivity, DO, chlorophyll A turbidity, and blue-green algae. Let's see the preliminary results that we get from modeling and analyzing those data which we collected in the field. Firstly, here is the SETI depth surface map across the lake. First, you can see the 3D surface plotting. On different depth here, you can see different dates, 28 June, 30 August, and 25 October. And different across the different location on every depth, you can see the 3D plotting of SETI depth and the depth profile. And the next diagram, you can see the relationship between the SETI depth and chlorophyll A. Since we have less numbers of data, still we can see the correlation between them, but as soon as I get much more data this summers, then I can present it on the better format and better way with better results. And the other thing we are doing is water quality index comparisons. We are planning to do 4 of the comparisons: weighted Arithmetic, Canadian Council, Modified Bhaskaran, and National Sanitation Foundation. For the preliminary way, we have calculated weighted Arithmetic and Canadian Council's method. By the both preliminary calculations, we are seeing that the water quality of Toppan Lake is not fit. It needs to be treated before sending for water supply, but it is still our preliminary study, so we can't conclude it for now. So we are analyzing 2 other methods for water quality health of this lake. And next slides, you can see that the thermal stratification and mixing cycle. We're analyzing the stratifications and overturning mixing of the lake to see how algal bloom growth is influenced by the nutrient upwelling and thermal instability in the lake. In the diagram, you can see that during the summer, the temperature at the top surface is quite high and at the bottom is quite low. And at the winter, you can see the reverse cycle. But during the overturn cycle, the nutrients on the bottom surface might be circulated to the upward surface, so that is providing that internal loading might be helping the algal bloom in the lake. That is what we are studying for. And this is obviously for model things. This is the temperature stratification that occurs on that Toppan Lake during March to October of 2024. On the March data, you can see that there is the stratifications on the lake. The temperature at the top surface is quite high and the bottom is quite low. But when the trend continuously goes and till the end. On the last graph, you can see that the temperature graph is vertically downwards. Almost the temperature from top surface to bottom surface is constant. So this overturning and mixing that I saw on the previous graph is influencing or uh, giving support to grow of algal blooms in that lake. Similarly, for the DO stratifications also, you can see the similar pattern. DO might be influencing the algal bloom concentrations. We are still looking at it. At the beginning of the data beginning graph, you can see that the graph is vertically downwards, and you can see the stratifications when the day moves ahead. Now here comes the seasonal heat map. We were analyzing the chlorophyll data across different locations on different days, and here you can see that the different dates on the top, and the chlorophyll data are filled across the depth. Now you can see the line on that graph that represents the peak value of chlorophyll A across different depths. At the beginning of the summer, the chlorophyll A concentrations was higher at the base of the lake. As the summer moves on, then the peak value of chlorophyll A is at the top. And yeah, okay. Similarly, the graph you can see for turbidity, it is quite turbulent on different days. There might be a precipitations or some boat mixings or something, but the turbidity is data is not that what we were expecting for. But let's see for the next summer also what results we get, so we can conclude about the turbidity across the profile on different depths. Now here you can see the simulated versus observed temperatures. We were using mean lake model without inflow and outflow conditions for the first time. So it is better, quite perfectly correlated in case of temperature. But it was the older versions of mean lake models. Now we are working with the developer with accommodating the inflow and outflow in that model. So in temperature profiles, our model is perfectly working. But in case of DO profile, since at Topon Lake, the water level is decreased by 4 to 5 feet at the end of summer. So there might be the difference shown by the outflow or inflow on the DO parameters. So we are looking at the DO. It still needs to be calibrated and validated. And here you can see the results of simulated versus observed temperatures with the R square value of 0.951. I don't have much to explain on it. And here comes the profile data from depth and plot across different depth. Here you can see that the stratifications which I explained on the previous graph also, this was our model which we used for temperature profile and DO profile. Similar results can be seen on the DO profile. The model needs to be calibrated, but in case of DO, the outflow were not considered at the beginning. Now we are considering it with the talk with the developer of that model itself. So let's see if we will get the better results of that. Now coming to the significance and impact. Firstly, the significance of this research is understanding the algal bloom dynamics, how the algal bloom is occurring by the internal loading or the external loadings, what is the major cause of it. And we are analyzing the water quality index to improve the water quality monitoring of that lakes. We want to understand the stratification patterns of the lakes, drowning, mixing of that lake. And we are modeling for this lake about the algal bloom reductions for the future scenarios also. And the future works which we are planning to do are we are developing 1D models with inflow, without inflow. We are developing Q8 models, and we are comparing it with the 3D EFTC models, which is being developed by my fellow. And apart from that, we have already calculated 2 water quality index, but now we are still developing modified Bhaskaran and National Sanitation Foundation's water quality index. And now we are also coupling the Q8 model we developed with QSWAT to see the results. Of course, validations and calibrations of those models. And apart from that, we still want to see how does the internal loading of that lake is helping the algal bloom. So we are thinking of using ADCP and see the sediment suspension that is happening on the lake. So the expected outcomes are algal bloom predictions, understanding seasonal stratification patterns, and water quality index comparisons. Okay, and that's it. And thank you for your
Thank you.
help.
Thank you so much, Dujan. That was incredible. Does anyone have any questions? Well, I appreciate your research is so thorough and oh, all right. So and very impressive. We have one question. Does the water level, the volume, seem to change significantly? Did you notice any of that in your research?
Okay. At Topon Lake, the water level is reduced by 4 to 5 feet at the end of the summer. So that's the major change that occurs on the lake. Actually, it is a reservoir, controlled reservoir. So yes, there is a reductions in volume of water at the end of the summer, but not on the other time. Yes, we are considering it for better results.
Thank you. Awesome. Well, that's going to wrap up this time, and I'm going to go ahead and introduce Liliana Kajek, who will share more about microplastic occurrence in the Buckeye Hills Region Council, which is going to include geographic and socioeconomic influences on drinking water. So thank you so much, Liliana. She will be pursuing her graduate degree from Ohio University in the Master of Science in Environmental Studies program and is graduating in this May also. So congratulations.
Thank you so much. Everyone did such a wonderful job presenting. It's such an honor to be here. So yeah, let's just get into it. I'm going to talk to you guys a little bit about some of the research that I've done over the last 2 years it's coming up on. So let's get right into it. As we know, microplastics have become an increasingly prevalent concern for both environmental and public health in recent years. Microplastics are broken down fragments of plastic waste, often ranging anywhere from 1 nanometer to 5 millimeters in size. And the more research being done on microplastics reveals its extensive contamination in every single facet of the environment and our daily lives. So drinking water has revealed itself as one of the primary pathways of microplastic consumption by humans. As a comparative analysis on studies testing microplastics in drinking water treatment plants specifically revealed over 80% of studies have reported an occurrence of microplastics in their systems. So my research questions include, do microplastics exist in drinking water treatment plants within the Buckeye Hills Regional Council of Southeast Appalachian, Ohio? Is there a relationship between the microplastic levels in drinking water and socio-demographic and geographical characteristics of that region? And also, can inline sampling techniques be effectively applied to studying microplastics in drinking water? So little attention, as we all know, has been paid to the Appalachian region in terms of scientific research as a whole. But for microplastics in drinking water specifically, this research provides some of that initial data. Ideally, this research would also further push scientific consensus towards an efficient and widely adoptable technique for sampling drinking water, which in turn allows for ease of comparison between studies. And then, as we all know, the established health implications associated with microplastic occurrence and human ingestion highlight the importance of studying its concentration levels in drinking water specifically. So there have been a myriad of studies that have revealed the presence of microplastics in several sources of drinking water. And those studies have ramped up. There's still very little global consensus on proper sampling, extraction, and quantification procedures of microplastics. But new research suggests that inline forms are the most successful because they allow for larger volumes of water to be tested while also avoiding exposure or contamination from the surrounding environment, and often yields more consistent particle counts as compared to the most common in laboratory methods that we see in most studies today. Additionally, studies have revealed significant relationships between socioeconomic and geographical indicators like population density, economic status, larger urban land coverage, and wastewater treatment plant effluent, as well as elevation. And so with that all being said, that kind of formulated what my thesis now looks like. So what I did was I took samples from 10 different drinking water treatment plants throughout 5 of the 8 participating Buckeye Hills Regional Council counties. So I used an inline method of filtration directly from a tap faucet or a spigot at the facility. So there were 3 facilities in Athens County, 3 in Washington, 2 in Perry, 1 in Hocking, and 1 in Meigs County. All of the samples were taken between September and November of 2024. Each facility was visited twice, taking 3 samples per event of 2.5 gallons per filter paper. So just a little rundown, the Buckeye Hills Regional Council, it's an influential grassroots organization that works with a lot of local stakeholders in the region to ultimately improve socioeconomic conditions and foster strong communities in this area. So it includes 8 total counties and approximately 250,000 residents throughout 3,697 square miles, and also is widely diverse in societal makeup, socioeconomic status, and geographical features. And this is what the area that the study was taken in. So this is basically just some basic information about the facilities and their county and their town that I used for my statistical analysis. So I was looking at per capita income, poverty level, population size, population per square mile, as well as the drinking water source, whether that be ground or surface. So as you can see on this map, all of my participating drinking water treatment plants are identified with the little red icon there. So the materials that I used include a 47 millimeter stainless steel filter house, a 10 micron pore size polycarbonate membrane filter, and a totalizer for drinking water. And so that's just like a basic little demonstration of what it looks like. And then I'm going to show you what mine looks like specifically all together. And so with this mechanism itself, there are a lot of challenges in terms of having attachments that fit all of the varying facilities that I visited. So I had a multitude of little attachments that I included with my project and brought them all with me and kind of switched the mechanism around to fit whichever facility I was sampling that day. And then here is basically just a step-by-step guide to help me get through all of the sampling in a way that I can be consistent with my methods. And this helped a lot in terms of just keeping everything consistent. In terms of quantification, I used a digital microscope with a full screen and photograph capabilities. I used visual counting methods to quantify and characterize all of the particles on each of the 60 total filter papers. So they were divided into 4 quadrants, and then I followed a serpentine pattern up and down each of the quadrants and making sure to count each quadrant 2 times before moving on to the next. And the only particles that were officially counted had to include some of these very specific characteristics like shape. So they had to be in the form of a fiber, fragment, or film. These are the most common microplastic types that most people see in scientific research. Additionally, the color, I was looking for things that are not naturally occurring, like blues, reds, greens, purples, yellows, stuff like that. And then I also was looking at the texture. So did it have a jagged or a rough edge? And then was it durable when poked with a hot needle? And then, like I mentioned, fibers and fragments are the most common in a variety of microplastic studies, from marine ecosystems to soils and sediments and drinking water, of course. So here are just a few pictures of some of the filter papers that I collected. This one is from one of my surface water facilities. You can see there are quite a few green and blue fragments visible. This is a groundwater facility with a very prominent pink fiber, but also some little blue fragments as well. And then just one more that had blue and red fibers and green fragments. And that was also from one of my surface water facilities. So to ensure high quality data, the use of the inline filtration system to collect the samples already kind of does that for me. It allows me to test in a controlled, relatively contamination-free space. Sampling directly at the facility allows me to kind of cut back on some of that excess debris that I would have run into from the aging or degraded service lines, which are very common in this region of Appalachia. Flushing the spigot for 1 minute prior to sampling also, just helped get rid of some of that additional settled debris that existed in the tap. The use of the totalizer to make sure that all of the filter papers were the same amount of water, and then naturally cleaning the mechanism after each use. In terms of analysis, I used RStudio to understand if a significant relationship existed between microplastic occurrence and per capita income, poverty level, population size, and population per square mile. So I used a linear regression. And then for the source of water, I used a Wilcoxon rank sum analysis to see if there was a significant difference between ground and surface water facilities. But it is important to note that I was unable to attain equal sample sizes for both groups. So my test is limited in statistical power, and the confidence intervals are quite a bit wider. So I will say though, every single filter paper that I sampled or that I looked at had microplastics on them, but there is no statistically significant relationship between these indicators that I had mentioned and its level of microplastic occurrence, though population per square mile was very close. And then while the data that I have currently does not indicate a statistically significant relationship, some additional data, both in the number of samples as well as the participating facilities, could, with more widely diverse socioeconomic indicators, would ultimately improve statistical power and potentially reveal underlying associations that I could not see with my current sample size. As I noted before, the majority of the participants are in the lower income category as compared to, somewhere maybe in like Columbus. That might be helpful. So this is just a bar graph just so you can see the mean microplastic abundance by facility and round. Somerset was the surface water facility, but there were a few outliers. I decided to keep them in just because I felt confident in my counting capabilities. This is just another microplastic abundance by facility, so you can see kind of what we're looking at. And then this is microplastic abundance by water source. There were a lot of limitations just with making contact with potential participants in the beginning, working with facility operators, mayors, and my own schedule as a graduate student. And then, like I said, the inability to obtain an even amount of ground and surface water fed facilities. And then just beginning challenges getting my mechanism to work. And then the biggest limitation of all was just the lack of time, having to work through this process. But these findings ultimately provide an idea about the distribution and occurrence of microplastics in drinking water within this region of Appalachia. There were no significant relationships that I noted, but I will say the inline sampling techniques proved to be an effective and efficient method for sampling. And this research just ultimately contributes to a growing body of knowledge on microplastic abundance in the environment and drinking water, and ideally will pave the way for some more comprehensive investigation in the future. And that is all I have.
Thank you so much, Liana.
Thank you.
That was incredible. Do we have any questions? Oh, okay. I'm going to read one from
the chat.
Yeah. Thanks. In many aquatic environments, microbial communities are not evenly distributed, but tend to be concentrated on surfaces. Do you know if anyone is studying microplastic particles with respect to their role as carriers of aquatic microbes?
I know there's a lot of research about microplastics as having the capacity to act as vectors that carry and transmit pathogenic bacteria. I don't know of anyone in this region in particular who is studying that, but I do have quite a few friends that have also been working on microplastics in macroinvertebrates and in surface water reservoirs.
Great. I'm going to read a note from Brewster as well. He says, I just love how you were able to show the particles of microplastics on the filter paper. Such a great way to help people understand that these particles are in the water we drink, swim in, etc. Is there any way water treatment plants can filter out these microplastics?
As of right now, that's not looking likely. Like I said before, a lot of the facilities that I sampled at were in predominantly lower income communities. And so, with that being said, their treatment processes may not have been as advanced as some of the areas that had more funding available to them. I would have to say that I'm just not quite sure at this point.
We have one more question in the chat from Jan. Do you think that there might have been different results if samples were taken at a different time of the year?
That's a good question. I actually have no idea. I mean, I know for sure there's going to be variation in samples, and also variation just with me having to use my eyeballs to count all of these particles. But I can't say that I would know if there's like a seasonal variation with the abundance of microplastics. I think they're just ubiquitous in the environment and in drinking water plants.
Lily, I think you may have mentioned this, or maybe you didn't have enough data to be able to answer this, but was there a difference between drinking water plants that got their water source from surface versus groundwater? Thinking that maybe groundwater might provide some,
Yes.
a pre-filtration.
Yeah, so my original thought would be that surface water facilities would have more microplastics just because their reservoirs are open to the outside world and to humans who create plastic. But like I said, I wasn't able to obtain an even amount, so I only had 2 facilities that were surface water fed, and the other 8 were not. I will say though, the Wilcoxon test that I did run was close to being significant. So if I had to say, if I had more data, I would deem that surface water and ground were significantly different from one another.
But they still had it. I
Yeah.
guess is your point, is the distribution and prevalence is there across all the plants.
Yep, across the board, it exists everywhere.
Yeah. Which is bad news for us.
Yeah, not great.
Well, thank you so much. We have time for one more question, but if not, I just want to go ahead and share a big thank you to our incredible presenters and all of our attendees today. Just along with the speakers, I believe I expressed the same gratitude to Orba for creating an opportunity to highlight student voices. We appreciate all that you do to support the next generation, our continued efforts to advocate for the Ohio River. The research today is just a testament to the incredible work being done in restoration and the college level and beyond. So we are so thankful for this opportunity. And one more thing before we wrap up too, just as a final announcement, if you didn't hear it when we were coming in, remember to register for the additional Ohio River Basin Discussion Series webinar that will be held around mid-April. Register on the Orba webpage on the ORSINCO's website. But with that, I just want to thank all of our researchers again and appreciate everything that you all are doing.
Thank you so much.
Thanks, Ella. Thanks, presenters, and thanks, folks, for being here today. If you have future ideas for this Orba Ohio River discussion series, please send them to Chuck or I. We, run these each year in the winter, January, February, March, and this year, like Ella said, we have a special April webinar that will focus specifically on the Ohio River Restoration Initiative that will be out for public comment soon. And so we have folks from Orba that will be talking and presenting about that restoration initiative in April. Thanks, everyone. Have a great day.
Thanks, you guys.